Hi, good day everyone. So today we will be doing January 2025, number 8. Let me just click on this. Jan 2025, number 8. They told you the functions are defined as followed. F of x is 1 plus 3x over x minus 1, where they tell you x cannot be equals to 1. And g of x is x minus 5 minus x. Calculate the value of f of minus 2, which means that x is minus 2. Whatever is in the brackets is what x is equal to. Right, so f of minus 2 is equals to 1 plus 3 by minus 2 over minus 2 minus 1, which is 1 minus 6 over minus 3. Minus 3. 1 minus 6 is minus 5 over minus 3, which is positive 5 over 3. 3 could go into 5 one time, remainder 2 over 3. So it's 1 and 2 over 3 is the answer. Alright, determine and simplify the value of g f of x. This is a composite function. So, sorry, f g of x. So f g of x, we're going to separate the two with brackets, so it's going to be f, instead of g of x, we're going to put 5 minus x. Right, what does this mean? Wherever I see x in my function f, I'm going to put this. So this is going to be f of 5 minus x will be 1 plus 3 by 5 minus x over 5 minus x minus 1. Let's reduce this. This is going to be 1 plus 5 3s are 15 minus 3x over 5 minus x is 4. That's 4 minus x. Let's reduce this some more. 1 plus 15, 1 plus 6 is 16 minus 3x over 4 minus x. And we can leave it like that if you want. Yeah, leave it like that, and that would be your answer for this question. Alright, let's do part 3 now. Derive an expression in terms of x for the inverse of f inverse x. So first of all, let's just take a picture of this and put it here so I'll see it. Okay, so let's go. So the first step, whenever we have to find inverse, it's a 3-step process. First step is to let y be equals to the function. So you're going to let y be equals to 1 plus 3x over x minus 1. Right? Step 2 is to interchange x and y, meaning wherever you see x, you put y, so it'll be x is equals to 1 plus 3y over y minus 1. Next step is to make y the subject. Now please note, you are seeing two sets of y, so at some point you will have to factorize, right? So I have x is equals to 1 plus 3y over y minus 1. I carry in this entire divide by y minus 1 will turn to multiply, so it's x by y minus 1 is equals to 1 plus 3y. That's xy minus x is equals to 1 plus 3y. You make a choice of what side you want y to be on. I'm putting all the y's on this side and bringing everything else across on this side. So it's xy minus 3y is equals to 1 plus x. Because there are two sets of y's, I'm going to factorize all the y's. So y by x minus 3 is equals to 1 plus x. Relationship between y and this bracket is multiplication. So if I carry this across, y is going to be 1 plus x divided by x minus 3. So therefore f inverse x is going to be 1 plus x over x minus 3. And that is going to be your answer for this one. Alright, let's go directly into part B. Right, so part B, we can see it's a velocity time graph. So let's zoom in. Right, the velocity time graph below describes the journey of a car over a period of 70 seconds. The journey is represented in 5 stages, 1, 2, 3, 4, 5. Right, complete the following statement. During stage 4, The car is traveling at stage 4. That would be between 40 and 50 is 45 meters per second with an acceleration of, because that is a straight line or a flat line, the acceleration is 0, so it's a uniform acceleration, so it'll be 0 meters per second squared. We know acceleration is the change of speed or the change of velocity with respect to time. There's no change of velocity, it's a straight line, right? So it'll be 0. Determine a maximum acceleration during the 70 seconds. So they want to know which one has the maximum acceleration. Acceleration could either be in from here to here, from here to here, or deceleration, which is from here to here. I would not use the deceleration because deceleration is negative. It's always negative, so I would not even use stage 5. So I'll be looking at stage 1 and 3. To find the acceleration, we need to find the gradient. So let's find, this is 0.00. This is x is 15, y is 20. Hold on. This coordinate here, x is 25, y is 20, and then this coordinate here, x is 35, y is 45. Yeah? Right. So we need to find the gradient of those lines. The gradient of 3 is going to be 0, the gradient of 4 is going to be 0. This here's a deceleration, so I won't even use that. So I need to find either at stage 1 or stage 2. So the gradient of for stage 1, or the gradient for the acceleration for stage 1, we know gradient is y2 minus y1 over x2 minus x1. Depends on what you want to use. I'm using this as group 2 and this as group 1. So it's going to be y, which is 20 minus 0 over 15 minus 0, which would be 20 over 15. 20 divided by 15 is 1.33. So 1.33 meters per second squared. That is for this one, 1.33 meters per second squared. Right, let's look at for stage 3. The acceleration of the gradient for stage 3 is equals, again, same thing, y2 minus y1 over x2 minus x1. It's 35, 45. Let's just take those points. It's 25, 20, and the next point is 35, 45. 35, 45. Right, I choose x1, y1, x2, y2. So that is going to be 45 minus 20 over 35 minus 25. Right, 45 minus 20, 45 minus 20 is 25. Right, 25 divided by 10, which is 2.5 meters per second squared. They want to know which one is the maximum. That means the highest, which would be stage 3, which is 2.5 meters per second squared, or you could put 2.5 meters per second squared. Whichever one is correct, right? Calculate the distance traveled during the first 25 seconds. The distance traveled in a velocity time graph is to basically find the area. So for the first 25 seconds, that is here. Let's use red. Right. So this is a trapezium. So area of a trapezium is a half a plus b times your height. A and b are parallel sides. Height is, well, the height, the perpendicular height. That's a half. What is a? From here to here is 25. Right, and then from here to here is 10. So that's 15. The 25 is 10. By a height from here to here is 20. Right, so you just put exactly that in your calculator. 1 over 2, open bracket, 25 plus 10, close bracket, by 25, multiply by 25 you're going to get an answer 437.5 meters squared, or 0.5 meters squared. And that would be your answer for the area of the distance traveled for the first 25 seconds. I just now went over my calculations, guys. Something wrong here. It is 1 over 2, open bracket, 25 plus 10, close bracket, multiplied by 20. I think I multiplied by 25. That is probably the reason why I got this wrong. So I made a mistake. Let's just zoom in. So this here, when you calculate it, you're gonna get 350 degrees. Not 300, sorry, 350 meters. Right? And that is how you would find the distance traveled for the first 25 seconds. Again, to find the distance traveled for the first 25 seconds, you need to find the area under that, under the graph. And if we look at that shape here, we see it's a trapezium, right? So let me just paste this, put this here where it's supposed to go. So the answer for this is calculated distance traveled 350 meters. And that is the answer for number 8, paper 2, January 2025.